Very much. Nice to see so many people in the room. It's during my years here, it's not very often that you see a full Beijer Hall. So it's very nice that you took your time to come here on this Swedish Valborg Day. Can I get the first slide there? Okay. Okay. Ja, till och med. Vad ska jag göra? Det låter manligt. Nej, det händer ju ingenting. So meanwhile, I should have perhaps do some singing and dancing, but I'm not so good at Swedish students' songs. But just to put in context a little bit what I'm trying to talk about today in relation to the previous speakers, I think the issue of uncertainty and complexity that was raised earlier before the coffee break is really a key issue. That we're turning from an era where we were assumed as scientists to deliver facts all the time, to a recognition that we're living with true uncertainty and complexity. And what we can do is try to mobilize and gather the best knowledge we have to address that uncertainty and to help us navigate our own future in that way. I think that's a sort of different perspective of science that is very important, that it becomes known in broader context. And I think that's one reason also for your public, Mike, your public confusion of the science. So I think we should look at science as just one knowledge system that through some types of systematic approaches try to gather the knowledge and look at it in a way that can help us navigate society better for the future. That is my take on it. And now it would be really good to get the overheads, but
well, since we work on dealing with surprises,
okay.
We appreciate this. For some reason, the projector took a break, just as we other. So, but now it might be on its way to wake up. No, but we can take the opportunity. Is there anyone who'd like to pose a question to? There you go. Then we take that back.
So this is a picture that illustrates what Johan alluded to, and also to some extent the other speakers, that the new era we're in, that we're really on a planet where people are shaping processes not only locally and regionally, but also at the global scale. And if you look at this picture, I think it's an important picture, not only in terms of that people are shaping things, but this whole idea of talking about society here and nature there, or society here and the environment there, which we still tend to do, or talk about natural sciences or social sciences. That's, in my view, it's the wrong cut. It's an old-fashioned way of organizing knowledge in a situation where we're really facing challenges for our own well-being on the planet. So that's one of my first positions. Another one is that it's not about saving the planet, it's about us on the planet. Will we be able to live on the planet or not in the future? The planet will continue to exist, of course, and as long as the sun is in a good angle to the Earth, and life probably can take no other forms, but it's about how we will live on the planet and our own future. That's a bit about this concept, Anthropocene, that Paul Crutzen coined. Another important point of this perspective is may seem very obvious, but in my mind it's very crucial, and that's that the economies and societies are part of the planet and not the vice versa, which we sometimes seem to believe when we make decisions in society. That it's about if we can incorporate some of these values into the economic values, or if we can incorporate them into society. But it's really about the Earth system and its life support capacity being the very foundation for a good economy and a good society. And I think that, to my mind, that's a core feature of sustainability. And if you think about most of the debates today, we're talking about how we use the environment is often an issue in society, pollutions in society, or how much energy we use for running society. But the role of living systems in supporting us with services is often not part of day-to-day activities in society. So in the Resilience Center where I work with Johan and also in the Bayer Institute, we are framed by three entrances, you could say, in our research, which we think are important for us. And I don't say that everyone should use these ones, but we use them at least. And the first is the one I just talked about, the interdependent social ecological systems. The other one is what you heard about Mike and talk about uncertainty and complexity, and Johan mentioned thresholds and tipping points and these type of issues. You're facing complex relations. And the third is really something very important, is how different scales or levels interact from the local up all the way to the global and from history to today and into the future. These temporal and scale interactions, which are conventionally in science not very well addressed actually. So if you go to so many of the social sciences, they're often at one scale, or even in the natural sciences at one scale. So you mentioned climate data, for example, is often at very long time scale. But the whole interaction between the scales is very important, and also in space. So these are three issues that frame our research. Here is an issue that may look, a picture that may look horrible, but it's to illustrate that the climate issue is not a separated issue, of course. And also linking it to this point that the Earth is an interconnected, interdependent system. We had a paper that is now in review that we worked on last year with Victor and I and several others, where we tried to identify some of the drivers now that are operating at global scales, all the way from the ones that we heard about a bit in this morning, especially that one, and another one that is on the table together with the discussions in Mexico. The connectivity in itself, our own scale increase and how much resources we use, nuclear issues, things like shocks in that domain, and the whole financial system. These are drivers that then create sort of shocks and feedbacks in both climate systems, ecosystems, human health, and economic systems. And they interact. And they in turn create feedbacks here. So it's very difficult to talk about the climate issue as an issue that we should solve in itself, because it's connected to these other feedbacks. And if you look at it from a scientific perspective, and Mike said it in relation to IPCC, but I think that's a general statement for the science community. We're really ill-prepared for dealing with these type of bigger pictures in the science, because we tended to go into different boxes or different aspects of parts of it and become specialists in it. But this bigger picture, I think, is really important for the science community to mobilize knowledge around it, to help in decision making. It's not, of course, an easy issue. It's a very complex issue. I'll give you one example of this dynamics across scales from the Borneo rainforest and related to these type of shocks that I showed in the earlier picture. And in this case, the El Niño events that are part of the development of many of the tropical regions. The rainforest, for example, when the El Niño event comes, is heated up a bit, so it gets a little bit warmer internally, and that triggers enormous reproduction of seeds that are thrown out over huge areas. And the reason for that is that synchronized reproduction avoids predators eating up all the seeds, so you can have a new forest being revived and regenerated by it. So this is a core issue of resilience, that if you have a shock or crisis, an unpredictable event into your system, you can use it for development and for an opportunity. In this case, evolution uses El Niño for regenerating the forests. What has happened here, is that large part of Borneo has been deforested for global markets. So here comes a global driver in, landing on a region on Earth. And both for timber, but also for these plantations of oil palms, which palm oil is used in many different food sources in our world, in our part of the world. So it's really become a huge monoculture in many parts of the world, palm oil. And then when El Niño later arrived, it heated up the environment, and then you got the fires instead, triggered by humans also. So in 97, for example, we had a huge fire, you may remember that, on Borneo, that contributed that year to about between 25 to 40% of the whole emissions of carbon dioxide that year. So it's an illustration of how the global interaction from demand among people like us for oil palm in different commodities can push a system into a threshold, and then instead of having El Niño as a regenerator, you get it as a trigger for releasing a lot of carbon dioxide into the atmosphere. So currently 35% of human-induced carbon dioxide equivalents comes from land use changes. And that's often an issue that's not often so much discussed when it comes to abatement, but the whole idea of using land, ecosystems and ecosystem services in a different way in that context becomes very important. What has happened now in many ecosystems is that because of our activities, we have started to push them to thresholds and tipping points. And here are the three most studied ecosystems that have really been clarified, the different feedbacks, what is happening. A lake that goes from clear to muddy, a savanna that goes from productive grassland to bush landscape, which you can't use for food production. A coral reef that goes from coral-dominated system to an algae-dominated system. That's happening in large parts of the Caribbean. And when these type of shifts goes on, and they've been described for numerous ecosystems today, there is a shift in resource production and in ecosystem services. So that impacts on people's livelihood and well-being. Another classical one is from the Sahara that Johan mentioned before. And it's very tempting for scientists to use long time series for checking data. So here's a really long one. It's a couple of thousand of years. And you would be very tempted then, at least in the older days, to draw out a prognosis from that curve to see what the future may hold. And this is Salvador Dali's moustache in that context. But what happened was that we really had a big threshold, a regime shift or tipping point here. And these are some of the tipping points events that Johan showed in when it came to Schellenhuber's work in his first graph that we're facing now on the planet. And the group that Johan and several people were involved with tried to estimate some of those big challenges on a global scale. It's a paper that's right now in a review, not only the climate issue, but adding several others, sort of boundaries or key features of the Earth system that has to work in a certain way for us to be able to live on the planet, basically. So it's sort of radical to start to address the foundation of the Earth to function as a system for us to live on it. But here are a few of those. And I think you will hear more about that later on in the discussions. It brings us to the resilience challenge. How can you turn crisis into opportunity, basically? If you don't have this resilience, which basically in a popular language means capacity to deal with change and continue to develop afterwards. If you don't have it, you're vulnerable, because if something happens, you can't do anything about it, and you get trapped or collapses, basically. Three features again that Johan showed, but I think it's important to highlight those. Most people think about resilience as only this one, persistence or robustness. And the Santa Fe Institute, for example, works a lot on robustness, and other people, I think Simon Levin, that might probably knows that Princeton used robustness. It's basically the persistence idea. But the two other points I think we are more interested in, and that's the adaptability. If you have resilience, you can also do something with it. Basically, how can you deal with changes, and how can you manage your society to deal with these type of crises? And that's what Mike alluded to as a challenge for IPCC, that really bring that adaptation issue onto the table. The third one, the more promising or more visionary, perhaps interesting one, is the transformability one. How can we make use of crisis to direct ourselves in new directions that may become sustainable, basically? And here is what the Resilience Center is trying to focus quite much on, that transformability part right now. In connection to those, pretty similar like the earlier one, but the challenges are, how do you deal with this type of persistence when you're faced with tipping points and regime shifts and all those challenges? And those are, again, being highlighted a lot by natural scientists, but there are no solutions or strategies for how to deal with them coming up, basically. This is, again, the adaptive capacity. How can you deal with these type of changes, including the uncertainty? And here things like how do you create platforms of learning and knowledge generation involving not only scientists but other stakeholders and things like that coming into the picture. And again, the transformability issue. The Millennium Ecosystem concluded, not very surprisingly, that our institutional capacities to manage this dynamic Earth are evolving more slowly than our current overuse of the system. So that's a really big challenge for humanity that came out of the Millennium Ecosystem Assessment. And I think that's one of the guiding principles for us here in Stockholm also when we look at those issues. How can we develop improved management and governance systems to deal with this overuse and turn it around, basically? Here's an example that is very often talked about in the literature from social sciences perspective of collective action, basically how people come together and make decisions as a group. And that's from the main lobster fisheries that has been described very much as a very successful management system. One of the few that really seems to have worked for a long period of time. And people have developed lots of norms and rules, which is the definition basically of institutions locally for how to manage lobster and to not overexploit it. And that's been successful. It's been linked up to other levels. It's been linked up to the state domain and also to global markets. And sometimes you probably buy lobsters here in Sweden from Canada or Maine. So it's a really functioning social resilient system, so to speak, in terms of delivering lobsters. But when you look at the indicators they have used for success, it's population model basically of the lobster not overexploiting the lobster. All other fish species have been overexploited earlier, but not the lobster. So that's sort of the success. But if you expand analysis into the broader ecosystem, you discover that the lobster is there because all other fish are gone, including those fish that ate the lobster. So the lobster has expanded underwater as a big monoculture, basically, huge monoculture, and sustains the supply of lobsters for the management system, which has not really been recognized by the social scientists when they did the social analysis of the lobster system. So what's happening now is that probably because of global warming, the temperature in the water is a little higher, and outside Cape Cod, a little bit further south, diseases are appearing. And the disease there has wiped out about 75 to 80% of the lobster population. And now it's sort of an accident waiting to happen here in Maine, where the disease probably is moving up there fairly soon and may hit the lobster populations there as well. And again, that's from a resilience perspective, it's not a very good strategy to invest all your resources in one commodity. Those who have been on the stock market are probably well aware of that, and that you don't invest all your money in one company only. So here is a sort of a vulnerability created. It looks very resilient in the social domain, but if you disregard the ecological domain, but if you put them together, it looks like a real vulnerable social ecological system. And I think here's a challenge for us as a whole in society to stop thinking about the social part for itself and the ecological part for itself, or really look at it as an integrated system. That's an example of that challenge. And if I may comment upon the IPCC's work again there, I think that the adaptation focus in IPCC has largely been on adaptation within society, not on adaptations with ecosystems. So that's a new area that could be more developed. One way of looking at this is to see how can you develop better landscape and seascapes or ecosystem stewardship systems to build resilience of the combined life support system and the social system. And the Great Barrier Reef is one example of that, where people have actually changed the management from looking at the reef as a single system to really broaden the perspective and look at it as a whole seascape. And there you had a governance transformation that shifted the whole system from single disparate management to more unified management. We have identified several of those type of transformations in social systems, or when they start to do ecosystem-based management, that there is a phase of preparing the system for change, then there are windows of opportunities opening up, and then leaders and other social networks and other organizations and institutions help navigate that transition, and afterwards you can start to build a new direction. So that's an example of these type of transformations. And I think that Victor may raise some of those in your comments when it comes to dealing with shocks. And just finally, some adaptations lesson from those studies is that crisis, whether it's real or perceived, can trigger action and also innovation, which is very important in this context. That can reconnect people to the biosphere, basically, and that requires leadership and social network. And that preparing the system for transitions is very important, and I think that that's what's going on from the science community quite a lot. How do we, with knowledge systems, help prepare for these type of changes? Things that may look quite hopeless, nothing can happen, can suddenly very fast turn into a window of opportunity and make those shifts. And it's not enough just to put up legislation or other types of economic incentives. You have to have social relations and other types of people's interactions, including the psychological domain that Mike mentioned, as part of the game. So to just sum up what I tried to talk a little bit about here in this short talk is that sustainability in a climate change context requires strengthening capacity of people to deal with these type of changes, often sudden and surprising, and develop strategies that can turn crises into opportunities. That's the resilience argument. But it requires accounting for Earth's life support system as a whole, from the local to the biosphere, and recognizing that we're shaping it and are also depending on it. And we need social ecological resilience to be able to do that. Thanks a lot.